Hello class, welcome back to Physics 1. This is again Sir Alex Basco and we'll be discussing our lesson 2 for today. Last time we talked about measurement, units and conversion. Today we'll be talking about vector and scalar quantities. The goal for our lesson today is first, the goals basically is be able to differentiate what is vector and what is scalar. So ano nga ba ang vector quantity at ano ang scalar quantity? Second is to be able to perform vector addition. And third is to be able to rewrite a vector in its component form. So today we'll be discussing anong vector, anong scalar, how do we perform vector addition, different methods on how to perform it, and how to rewrite a vector from to its component, or how to find its component form. So let's discuss ano ba yung difference ng vector at scalar. What is the difference between a scalar and a vector? Mathematical quantities in physics may be scalar or vector. Scalar quantities are quantities that can be fully described by magnitude alone. Examples include mass, temperature, speed, time, work, energy, and distance. So these quantities can be expressed using just with a number. So for example, temperature, it's 30 degrees Celsius. Time, it's 5 o'clock in the morning. So it's usually uh, those quantities that has a number and just a unit. A number and a unit. 1 meter, 3 seconds, 5 kilogram. So those are example of scalar quantities. Vector quantities, on the other hand, needs both the magnitude and direction. Not only does it need magnitude, meaning it needs a number and a unit, let's say 3 newtons, or 4 meters, etc. But at the same time, it also needs direction. Examples are force, displacement, velocity, acceleration, momentum, and torque are example of quantities that has both magnitude and direction. So let's say force 3 newtons going downward, displacement 3 meters southwest or north of east, velocity 3 meters per second to the right. So not only do they have to have a magnitude, meaning the unit with the number, but also you need to know where the direction is. So scalar quantities are quantities that only has magnitude, while vector quantities needs both magnitude and direction. Let's talk more about vector scale. A vector can be represented by an arrow. So when we talk about vector, we use arrow to represent a vector. The length of the arrow is proportional to the magnitude, so meaning the higher the number, the longer the arrow. And then the direction of the arrow indicates the direction of the vector. Moreover, in this class for our Physics 1, we will be using two ways to denote the direction of the arrow. We'll be using the cardinal directions, the north, east, west, and south, and also we'll be using angles, and we'll be using the counterclockwise to east, or meaning counterclockwise from east line to a specified direction. What do we mean by that? So here is an example of the cardinal directions, north, east, west, and south. With we have vectors A, B, and C. Vector A is 30 degrees north of east. How do we write vector? So vector again is represented by an arrow, and the length is proportional to the magnitude of the arrow, and then the direction of the arrow is indicated represents or dictates the direction of the vector. So we have a vector going this way. To identify the direction of this vector, we can use the cardinal direction. So what we do is we add the degree, and usually we start the degree either from east or west. In this case, it's closer to east, so let's focus on east, and it's going up north. So this is how you write it. So you measure the direction from the east line. So this is 30 degrees, and the direction of the arrow is going towards north. So what we do is the angle north of east. How about a vector b? Vector b, this time it's going towards left. So it's in the west line and it's going up north. So it's north of west. So meaning it's going north from west. And then the angle is from the west line up to the vector. So it is 60 degrees from the west line to the vector b. How about it's going down south? So vector c is southwest. We use southwest, northeast, southeast, or northwest if it is a 45-degree angle. So as you can see, the west-south line is 90 degrees. This is west and south line, they're 90 degrees. And in the middle, half of 90 degrees is 45 degrees. So instead of writing 45 degrees southwest, we just write southwest. So if you see just southwest, northeast, northwest, that's automatically 45 degrees. And what do we mean by angles using the counterclockwise to east? So in this configuration, we always start the degree on the east line. So this is our east line right here. And then depending on the direction of the vector, this time this is 40 degrees. We just use the degrees. When I use degrees, we're immediately assuming that it starts from the east line. So this vector is 40 degrees. So when this vector is 40 degrees, it means it's 40 degrees counterclockwise rotation from east. This vector right here is 240 degrees counterclockwise to the rotation of the east. So if you see that a vector is written as 240 degrees, it means we start from the east going all the way to here. So this is 90, 90, that's 180, and then the rest of 240 is in this degree right here. So this whole degree is 240 degrees starting from the east line. So how about let's try some problems before we continue on. Okay, so it shows the directions of the following vectors. 78. So let's so let's imagine this as our cardinal angle. Okay, so 78 degrees south of east. So meaning we're going south and the origin is from east. So automatically we know that our vector should be going this way. Sorry if my lines are not perfect. So it says we're going south from east. So this is east. This is east. It's right here. And we're going south 78 degrees. So our angle is 70 degrees from here. My line is very okay. So that's 70 degrees. Next, 39 degrees north of west. So the original line is from west, meaning on this side, this is west right here, and it's going up north. So west going up north, 39 degrees. So we have our vector originally from the east, and it's going up at 39 degrees. So that would be our vector. And our angle, so remember it should be an arrow, so this should be an arrow right here. Okay, so our angle starts from west going to north, and this is 39 degrees Celsius. And again, this is an arrow because this is a vector. Next, 15 degrees southwest. So our original vector is in the west line and it's going south 15 degrees. So that's our vector right here. And the angle is going down and it's 15 degrees. So let's say, so this is the cardinal direction, angles using the cardinal direction. How about let's try doing it with the counterclockwise from east line. So let's start with 78 degrees south of east. So we know that this is our angle right here, right? So if you're going to write an angle, we're going to measure the angle using the C or the counterclockwise. We always start from the east, right? And then we have to go all the way here. So our angle for this situation right here is basically 90 degrees plus 90 degrees plus 90 degrees, and then plus the remaining here, which is basically 90 minus 78. So that is a total of 282 degrees. So this angle is 282 degrees. Okay. Number 2, we have 39 degrees north of west. So we identified that this is 39 degrees north of west. So let's change the color so it's not confusing. Again, for counterclockwise from east, we always start from east and then until we land where our vector is. So this whole angle is what? So that's 90 plus 90 minus 39. That is 141 degrees. Lastly, let's have number 3, which is 15 degrees south of west. Let's try different colors. Okay, so this is our angle right here. So it's 15 degrees. So what we want is we want again to start from east, going all the way here. So that's 90 plus 90 plus 15. That is 195 degrees. So this is our CCW, counterclockwise from east, and this is the counter, or this is the cardinal angles using the cardinal direction. This is 2 ways to identify the direction of our vector. And I want you guys to understand this because a lot of times we'll be using either the counterclockwise from the east, or most of the time we actually be using counterclockwise from the east, but sometimes we'll also be using the cardinal direction. I hope that is clear. We're going to continue on. Okay. Operations on vectors. So this time we'll be doing some operations on vectors. Unlike scalar quantities that obey the ordinary rules of algebra, on addition, subtraction, multiplication, and division, vector quantities, on the other hand, are treated differently because not only are we adding the magnitude, but we also have to consider the direction. So vector addition and properties. So resultant is the sum of two or more vectors. So when we add vectors, the resultant is what we call the sum for two vectors. Vector addition is both commutative and associative. When we say commutative, orders may change without affecting the property. So if we have vector A plus vector B plus vector C, it should be equal to, if we change the order, it still equals to vector C plus vector B plus vector A. Associative property just means the grouping of the vectors does not affect the result. So if we add a plus b vectors and then multiply the resultant to the c vectors, it still be the same if we do a plus the grouping plus the resultants of b plus c. So we'll always arrive at the same answer. So that is some properties on vector addition. It is both commutative and it is both associative. So what are some of the methods in doing addition in vectors? There are two ways that we use, graphical method and analytical method. For graphical method, it usually requires a proper scaling. Later, I will show you what I mean by proper scaling. But also, unfortunately, it requires measuring tools such as rulers and protractors. Solving, and we can use graphical method using the parallelogram method or the polygon method, and we usually use head to tail method when we draw the polygon method. So for here's an example that we'll be doing. For all intents and purposes, I'll be only showing here how to do the graphical method, because a lot of times when we start doing more on our lessons, as we continue on, we'll be using the analytical method probably 99% of the time. Here I'm just showing you how to do the graphical method, but in the next upcoming when we apply the things that we learn here, we'll be using a lot of analytical method. So let's go and try sample problem number 1 for our vector addition. Two forces are acting on a particle. Remember, force is a vector quantity. It has a magnitude and direction. So force A is 3 newtons directed north, and the other force is B, 40, with 4 newtons, 30 degrees going north of east. Find the resultant using the parallelogram method. Okay, so what we want to do first is we draw a our northeast, west, south. Let's draw our cardinal. Uh, let's draw our cardinal direction. So this is north, this is east, this is south, and this is west. What we need is a vector. The first thing that we have to do is create a scale. What do we mean by scale? Since we are using measuring tools like rulers and protractors, then we have to change these numbers right here into a scale. So our scale would be, let's say, 1 newton is equals to, let's say, 1 centimeter. Okay, so we need a proper scaling. Next, we have to draw our vector. So let's bring out our ruler and not the compass. We need our ruler and our protractor. Okay, so the first one that we have to draw is force A, which is 3 newtons. So since 1 newton is equals to 1 centimeter, meaning 3 newtons is equals to 3 centimeters, and it's directed, so here it's directed north. So let's take our ruler, tilt it, and our vector is heading north. Okay, next. So we know that our vector is heading north and it's 3 newtons, meaning it's 3 centimeters. Okay, so that is our That's our first vector. So that's our vector A. Next, our vector B is 4 Newton. It's going 30 degrees north of east. So it's in east and it's going north. So we have to measure 30 degrees. So that's about right there. Okay, it's not perfect, so it's 30.1, but let's just say that's 30. And so it's right there. Okay, let's get our protractor out. Next is we have to tilt our ruler and create a line. And we know that our vector is 4 newtons. 4 newtons, 1 newton equals to 1 centimeter, meaning it's 4 centimeters. So our second vector is 4, is 4 centimeters. Okay, so that's our 4 centimeters. So now it's asking us to do a parallelogram method. The parallelogram method is when we have two vectors, what we do is we put the tails of two vectors together. So let's just write some of the elements. This is 30 degrees here, and this is our vector B. What we have to do now is to create a parallelogram using these right here. So in order for us to use the parallelogram method, what we have to do is create another line, and then we attach it to the tip of our, or the head of our vector A. So this is vector A. Okay, and then what we have to do is the same with here, and create and connect the two together. And now what we have is a parallelogram. So that is the parallelogram method of solving for vector quantities, or vector addition. And where's our resultant? So our resultant is the line connecting our vectors. So we start from here. What we do is connect a diagonal line from that tip here to the other end of our parallelogram. Okay, so our vector starts from here and it's going there. And to know the answer on what is our vector, maybe let's change the color so it's not confusing. Oh, okay. I don't think you can change the color. But okay, so this is our vector right here. This is our vector in the middle. So in order for us to solve uh, the magnitude of that vector, what we just need to do is to measure it using a ruler. And we know that it's about 6 centimeters. So what that means is that so our vector is 6 centimeters. Gosh, that's why I hate this. It's messy. So our vector, our resultant, is equals to 3 or 6 centimeters. Now what we need is to convert 6 centimeters using our scale. So if our scale says we have 1 newtons equals to 1 centimeter, then we just have to change it. 6 centimeter. We have 1 centimeter, and 1 centimeter is equals to 1 newton. Cancel, cancel. 1 times 6 is equals to 6 newton. So the resultant is 6 newtons, and the direction, so now we have to find the direction using our protractor. So starting from here and then right here. So that's 54.2. So let's say about 54 degrees Celsius, or not Celsius, just 54 degrees. So it's 54 degrees, 6 newtons, 54 degrees north, or east, north of east. Or basically just 64 newtons, 54 degrees, 64, 6 newtons. So this is our answer. So this is our full answer. We have the magnitude and the direction. So that is what we do in graphical method. Again, it's an hassle because we need the following. We need a protractor, we need a ruler, and it takes a lot of time to do it. What if you have a really long one? It's not very convenient. So what we're going to do now is we're going to learn how to do the analytical method, and I'm going to show you how to solve vector quantities using analytical method. Okay, let's continue on. Methods of vector addition continue. Analytical method. We solve for the resultant using the Pythagorean theorem and other trigonometric functions. Okay, so for analytical method, we need geometry, a lot of geometry and a lot of trigonometric functions. So example, we have sample problem number 2. Add the following vectors: 6 kilometers east, going east, 4.5 kilometers going north, 8 kilometers going west, 6 kilometers north, 3 kilometers west, and 4 kilometers south. Okay, so here's our example right here. For analytical method, we do not have to use ruler, so it's easier. We can just assume the length according to our the length of our arrow according to our magnitude. So first magnitude that we have is 6 kilometers going east. So we're basically just gonna draw let's use the red line here. So the first one is going east. So let's say this is 6 kilometers and it's going east. Okay, so this is 6 kilometers going east. Our next is it's going east, it's going west, and it's 8 kilometers. So let's try this. So it's 8 kilometers going west. So that's 8, let's say that's 8 kilometers. And the third one is 3 kilometers going west. So our third one is basically half of the first one. And it's 3 kilometers. right? And for our second one, we have 4.5 kilometers and it's going north. So you have 4 kilometers. Let's say this is going north, or 4.5. Say 4.5 kilometers. The next one is 6 kilometers going north. Let's say that's 6 kilometers going north. And the last one is 4 kilometers going south. Okay. For what do you call this? For graphical method, what you need to do to solve this is to connect using the head to tail fashion. So, for example, you have the vector here. It's going east, and then let's add your vector here. So what you want is you want to connect the head of the first vector to the tail of your second vector. Okay, so let's start here. Okay, so this is your 6 kilometer, and this is your 4.5 kilometers. It's a lot of numbers to move. And then the next one is, let's say, the 8 kilometers going west. 4.5 kilometers, and let's say we need these 8 kilometers right here, and then 6 kilometers going north. Again, so head to the tail, and then 3 kilometers going west again. Connect the head to the tail, and then we have 4.5 kilometers going south. So this is what you do in graphical method. And then after doing this, you have to measure this line. So you have to connect from the tail of your first vector to the head of your second vector. So it's not perfect, so around. So it's kind of this way. And then this is your resultant. This right here is your resultant. And then for, again, graphical method, just use ruler and protractor after you do the scaling, etc., etc. But for analytical method, what you just need to do is to follow the x and y line. So we know that this is our x and y coordinate. So this is our x, this is our positive x, this is our positive y, negative x, and negative y. So what you want to do is get all your x's. So our x's here is the east and the west, so all our red. So if it's going east, it means it's going to the positive direction. So that's our first vector is actually positive 6 kilometers. Our next vector is going west, so it's going to the negative direction. So what you want to do is add a negative sign to your vector if it's going west. And again here it's going west, so that's negative 3 kilometers. The next one is you want to get all your y's. So for y's, it's all the north and the souths. Okay, so if the thing is going north, then it's positive. So you have your positive 4.5 kilometer. And the next thing is kilometer, it's also going north, so that's positive. So we have 4 kilometers going south, so that's 4 kilometers, negative 4 kilometers. What you want to do now is to add all your vectors. So 6 minus 8 minus 3 is equals to negative 5 kilometers. For here, 4.5 plus 6 plus, oh wait, 4.5 plus 6, that's 10.5 minus 4 kilometers, that's 6.5 kilometers. Tama? So that's positive 6.5 kilometers. Okay. So this is your y and this is your x. What you want to do now is to create a component or vector for this. So you know that since it's negative, so it's going west. So what you have is we're going to use the red line. So what you have is something like this, and let's say this is 5 kilometers, and since it's going to left, that's going to west, it's negative. And then you have your 6 kilometers, 6.5 kilometers. So what you're going to do is again head to tail. So from the tail of your first vector, add your second, the tail of your second vector, and add, and that's 6.5. So what is your resultant? So your resultant should be, you have to connect the tail of your first vector to the head of your last vector. So you have something here, and it's going on this direction. It's not perfect, but it's something like that. So that is your, vector, or that is your resultant. And so how do we solve the resultant? If you see, this is a triangle and it's a right angle triangle. So what you just want to do is use the Pythagorean method. R squared is equals to 6.5 squared plus 5 squared. So the answer to that, if you add calculator, is basically, so 6.5 squared is 42.25 plus 25, and then that's r squared, square both sides, and what you get is 8.2. So your resultant is 8.2, so your resultant is 8.2 kilometers. Next is you want to use the after is trigonometric functions to solve for the direction of your resultant. So we have to find the angle here. What we can do is use SOHCAHTOA. If you guys are familiar with that, I mean you should be. This is from trigonometry and calculus. So let's use tangent. So tangent is equals to opposite over adjacent. So the opposite of the angle is 6.5. Sorry, that's 6.5 divided by, that's 5. So that should be tangent theta. So tangent, so the angle is equals to arctan 6.5 divided by 5, which is basically equal to, let's find out, which is equal to arctan of 6.5 divided by 5 is 52.43 degrees. So the angle here is 52.43 degrees. So the resultant vector, the final answer would be, your resultant is equals to 8.2 kilometer 52.43 north of west. Okay, so that is your answer. Okay, so if you guys have any questions, don't hesitate to contact me about that, but let's keep going. Okay, so when solving for vectors that do not lie on the traditional x and y axis, we must first resolve the vector. So this is easy to solve. Okay, let's go back. So this is easier to solve because basically all your vectors lie in the traditional x and y axis. So what if they do not lie in x and y axis? What you want to do is to resolve your vector. So we have, I'll show you later how to resolve the vectors. Resolving vectors requires that we must first find the vector's x and y components. So to resolving the vectors, first you must first find the magnitude of its component and its x component and y component. To find that, we use these equations right here. The magnitude for the x component is equals to the magnitude of your vector cosine theta. And for your y component, we use the magnitude of your vector multiplied by sine theta, where a is the magnitude of the vector, angle is the angle direction of the vector, but remember we have to use the counterclockwise to east or from east direction. So counterclockwise, we cannot use the north of east or southwest, we have to use the angle using the counterclockwise method. After resolving each vector, find the sum for each of the component. So we have the sum of each of the component. We can create a table to help, and then using Pythagorean theorem, we can find the resultant, and using trigonometric functions, we can find the direction. Okay, so basically what we did earlier. Okay. So let's try that with our sample problem number 3. Add the following vectors: 7.5 at this angle, 10 point this at this 10 point kilometers, 143, and 5 kilometers at 231.1. Okay. Okay. So what you want to do is, first we have our first vector is, so let's say it's 7.5 kilometers at 36.9. When we are using this method, we actually do not have to draw any lines because we have to use analytics and the trigonometric functions to solve everything. So first let's find the x and y component and the y component. So for the x component, we have to remember this equation: x is equals to a cosine theta. So our x component is 7.5 kilometers cosine theta, or the theta here is, sorry, is that that's 36.9 degrees, and that is equal to 5.998 kilometers. So for the y component, 7.5 kilometers but this time we have to use sine 36.9 degrees, and the answer to that is 4.503 kilometers. So this is your x component and this is your y component. And we have to do that to all our components. So you will end up with something like, let's move, over this. So this time we have 10 kilometers. So for 10 kilometers, the x component using a x is equals to 10 cosine, the degree for 10 is 143.1. So 143.1 degrees, that is equal to 7.997 kilometers. For xy, 10 kilometers sine 143.1 degrees, that is equal to 6.004 kilometers. And for the third one, for the 5 kilometers at 233.1, using the same equation, we'll get that the x component is equals to 3.002 kilometers and the y component is equals to 3.998 kilometers. So what you're gonna do next is, after getting all these numbers, is add all the x component and add all the y component. So what you can do is create a table. So you have all your x and all your y's. So you have 5.99, 5.998. So this is supposed to be negative. You have negative 7.997, and you have, and also these are all negative as well. Negative 3.002, and for your y component you have 4.503, you have 6.004, and you have negative 3.998. After adding all that, your x component is negative 5.001, and for your y component you have 6.509. After getting that, you can now draw your what they call this, your resultant. So remember, so this is the x components, it's negative, so meaning it's going something along in west. So let's imagine that's our x component, and then y components, it's positive, so it's going up. So we have about 6.5, and then your resultant, let's change the color. Your resultant, connect the tail to the head of your last component, and that is your resultant. Okay, so this is 6.5. Let's change the color. So this is 6.509, this is 5.001. And again, to solve for the resultant, what you just need to do is use r squared is equals to 6.509 squared plus 5.001 squared, and that's the Pythagorean theorem. Square both sides, and your resultant is actually equal to 8.208 kilometer. So your resultant is 8.208 kilometer. And lastly, you have to find the direction. You just have to find this angle right here. Uh, Again, you can use SOHCAHTOA. It's up to you which one you want to use because you have all the sides anyway. So let's try to use so that sine theta is equals to opposite over hypotenuse. So the angle is equals to arc sine. The opposite here, the opposite of your angle is 6.509, and the hypotenuse is basically your resultant. It's 8.208, and the angle is equal to negative, that's 37 point, it's actually negative 37.54. Remember, even though it's negative, since we're starting here and it's going up the direction of your angle, that's why it's negative. So your whole answer would be 8.2 kilometers at 37.54. That is north of west. So that class is your answer for this question. So that's how you use analytical using Pythagorean theorem and using trigonometric functions to solve for the resultant of two or more vectors. Okay, so if you have any questions about this, again, do not hesitate to contact me anytime. And I think that's the end of our lesson. It's a little long, but I hope guys you understand that. Thank you guys for coming and have a good day.